So in this part of the chapter, we are discussing about concentration of solutions. We said concentration can be expressed in mole per liter, which is molarity. We had problems on that. We also said that concentration can be expressed in percentage. Percentage. So percentage means, could be mass percent, which means mass of solute in 100 grams of solution. So the mass percent is obtained by dividing the mass of each element by the total mass of compound. If I'm going to tell you the percentage of carbon, let's say in sugar, I have to calculate mass of carbon in 100 grams of sugar. That would be percent of carbon in sugar. And this is solid sugar, no solution. And if I want to give you percent mass of oxygen in solid crystallized sugar, all I have to give you is mass of oxygen in 100 grams of sugar, then you can give me the percentage. I hope you are with me. So this molecule, which looks like a dog, it's ethanol, it's the alcohol which is in your beer, in your wine, in your drink. So the mass of 1 mole of this compound, all I have to do add total number of carbons together, which is 2 times 12 grams per mole, and 6 times 1 gram per mole, and 16 grams per mole. You add all of these together, you get molar mass, mass of 1 mole. You simply add all the masses together, all the atomic mass together, using the number of them, of course. You get molar mass. So in this, if I ask you to determine percentage of carbon in 1 mole, what is the percent of carbon in 1 mole of C2H6O, which is called ethanol? Ethyl alcohol, ethanol. You say, okay, in 1 mole of C2H6O, I have got 2 moles of carbon, and every mole of carbon is 12.01 gram. This is coming in periodic table, the number underneath the carbon. If you use it in grams, that would be mass of 1 mole of carbon. You divide it by total mass of 1 mole of molecule times 100, because it's percent, you get percent of carbon in this compound is 52.14. That's the percent of carbon in this compound. And then if I ask you, what is the percent of hydrogen in this structure? You take the mass of all hydrogen, 6 moles of hydrogen in 1 mole of ethanol. Every mole of hydrogen is 1.008 grams coming from the periodic table. Multiplied by 6, that's mass of 6 moles of hydrogen. Every mole of ethanol is 46.07 grams, so you divide mass of hydrogen to total mass of this 1 mole times 100, you say the percent of hydrogen in ethanol is 13.13%. And of course, if you want to calculate percent of oxygen, same thing, only 1 mole of oxygen, 1 mole of oxygen, 1 mole of oxygen, 16.00 gram, according to the table. That's the total mass of all the oxygens. Total oxygen in 1 mole a mass of 1 mole is 46.07 times 100. Because we are dealing with percentage, you get percent of oxygen. So now, if there is a reaction, I'm running a reaction, I get a product, I don't know what the product is. If I send that product for analysis to a lab, if it gives me these percentage, I know the unknown is ethanol. Its percentage, if mass percentages are different, I know the product is not ethanol. How do you check to make sure the percentage are correct? Obviously, if you add percentage of all elements inside the structure, it must add up to be 100%, 1 out of 1, 100%, 1 out of 1. So guys, often when we are doing research in the lab as a chemist, we mix things together, we expect certain product. Sometimes to get a mixture of product, you have to separate them, identify them to see what are the structure of different products. How do we find out the formula and the structure of product? The first step is to identify the empirical formula. Then we have to measure molecular mass, then we have the real formula. We have the molecular formula. So I want to give you, let me take this bar out of my way. And if I give you, so what is empirical formula? It's relative number of the atoms. In other words, if I look at hydrogen peroxide, there are 2 hydrogens. For 2 oxygens, the relative number of the atom is 1 to 1. That's empirical formula. This is called benzene. It's an organic compound. The ratio of the carbon to hydrogen is 1 to 1. So if the molecular formula is 6 to 6, empirical formula, which is showing the relative number of atoms to each other, is 1 to 1. So empirical formula is CH. That means the ratio between number of carbon and atom is 1 to 1. And if I'm going to look at this structure, C2H4, which is called ethylene, do you see there are 2 times more hydrogen than carbon? So I can say empirical formula, which shows the simplest ratio between number of atoms in a molecule is 1 to 2. And in this case, the ratio is 3 to 8. I can't simplify it anymore. Empirical formula and molecular formula are the same.